Good morning to all of you. We welcome you all. We are Department of Mechanical Engineering, Government College of Engineering, Bodi Naikanur. We are going to present the video lecture on refrigeration and air conditioning paper for final year BE Mechanical Engineering students. Our team head is Professor M. Balamurugan and team members are Professor M. Sabha Karthik and Professor M. Vinod Kumar. The subject code of this paper is ME8071. Objective of this paper is to understand the underlying principles of operation in different refrigeration and air conditioning systems and components. To understand the hidden principles of operation in different refrigeration systems, we are going to see what is refrigeration system and the types, and also study what is air conditioning system and what are the types. The second objective of this paper is to see the design principles and design of refrigeration and air conditioning systems. Introduction. This is the syllabus for first unit. In this unit, we are going to see the introduction of refrigeration. That means what is refrigeration and unit of refrigeration and COP. COP means coefficient of performance. Ideal cycle. Ideal cycle means ideal cycle for refrigerating unit. And refrigerant desirable properties, classifications, nomenclature, ODP and GWP. Introduction to refrigeration. Refrigeration may be defined as the process of reducing and maintaining a temperature of a space or material below that of surrounding. That means we choose the thermodynamic system. Thermodynamic system means a space or material, and maintain the temperature of the thermodynamic system lower than the surrounding temperature or ambient temperature. This means refrigeration. We choose the object and maintain the temperature of the object lower than the surrounding. This refrigeration process is accomplished by removing heat from the body being refrigerated and transferred it to another body whose temperature is higher than that of the refrigerated body or space. It means we accomplish this refrigeration by removing the heat from the refrigerator space and transfer this heat into the surrounding. One of the most important application of refrigeration has been the preservation of perishable food products, food processing, packaging, storing and transportation of food items by storing them at lower temperatures. Refrigerator system also used extensively for providing thermal comfort to human being by means of air conditioning. Air conditioning refers to the treatment of air so as simultaneously control its temperature, moisture content, cleanliness, odor, circulation as required by the occupants. Air conditioning means simply condition the air, control the temperature of the air, moisture content of the air, cleanness of the air, odor of the air. This is air conditioning. The starting point of refrigeration and air conditioning unit is from second law of thermodynamics. In second law, there are two statements: Kelvin-Planck statement, Clausius statement. Kelvin-Planck statement is for direct heat engine. Clausius statement is for reversed heat engine. So we see the only Clausius statement. In this statement, state it is impossible to construct a device that operates in a cycle and produce no effect other than the transfer of heat from a cold body to hot body. It means it is impossible to construct a device. Device means the refrigerator device or heat pump or air conditioning device that operates in a cycle. That means within the refrigeration system there is the cyclic process, and the system produces the only effect of transfer the heat from the cold body to hot body. This is the classiest statement. Naturally, heat always flow from high temperature body to low temperature body. But in refrigerator unit, we transfer the heat from the low temperature body to high temperature body. In this case, we have supply additional energy to the refrigerating unit to transfer heat from low temperature body to high temperature body. This is the black diagram of reversed heat engine. In reversed heat engine, this is the hot reservoir. The temperature of the hot reservoir is TH. This is the refrigerating system. This is the low temperature reservoir. The temperature of the low temperature reservoir is TC. So in the refrigerator system, we supply the additional power to the refrigerating unit, and this refrigerating unit transfer the heat from low temperature body, low thermal reservoir to high temperature reservoir. So this is the reversed heat engine. Q dot is the amount of heat removed from the low temperature reservoir or refrigerator space. This TC means temperature of the low temperature reservoir is lower than surrounding temperature. This surrounding temperature TA. So the heat always flow from high temperature body to low temperature body. Here high temperature body is atmosphere. Atmosphere to refrigerator space, the heat always flow. The equal amount of heat is transferred from low temperature body to surrounding by the refrigerating unit and maintain the temperature of the refrigerator space lower than the surrounding. Unit of refrigeration. Unit of refrigeration means a ton of refrigeration. It describes the heat extraction capacity of refrigeration and air conditioning equipment or the rate of heat transfer that result in freezing. Simply, a ton of refrigeration describes the rate of heat removed from the refrigerator space per second. We define the ton of refrigeration. We define the ton of refrigeration by we take 100 kg of water at 0 degree Celsius and convert this 100 kg of water at 0 degree Celsius into 100 kg of ice cube. During this process, some amount of heat must be removed from water to convert water into ice cube. The amount of heat removed from water is equal to mass of water and latent heat of the water. Mass of water 1000 kg, latent heat of the water 336 kilojoule per kilogram. Totally 336,000 kilojoule amount of heat must be removed from water to transfer into solid phase in 24 hours. We divide this value by 24 hours and we get 1 ton equal to 3.5 kilowatt. Coefficient of performance. This is the performance parameter for reversed engine. In direct engine, we use the efficiency of the engine. So the coefficient of performance is the ratio of heat removed to work input. Heat removed means the amount of heat removed from the refrigerator space, and work input. Work input means amount of work supplied to the refrigerator system. The COP of a reversed heat engine cannot be infinity. That means the COP of a value cannot reach infinite value. That means in this formula, the denominator values cannot be 0. If you put 0, the COP value is infinity. So, in order to transfer heat from low temperature body to high temperature body, we must supply additional work for that heat transfer process. An informal and quite popular version of the statement is, a refrigerator does not work until it is turned on. That means the electrical energy is used to run the refrigerator. If we don't switch on the refrigerator, it doesn't work. That means in order to transfer heat from low temperature body to high temperature body, we use some additional power. Thank you.